Okay, good morning children. So in the last class we had discussed about the topic mechanism of enzyme catalysis and some industrial important enzyme catalysis, right? Do you have any doubt in this topic children? Nothing, right? Okay, Steffi, can you tell me which are the two steps for this enzyme catalysis?
Ma'am, I was not there.
Sharon, can you tell me?
Binding of enzyme to substrate to form an activated complex.
Yeah.
And second point, decomposition of the activated complex to form product.
Yes, okay. Then Aditya, which is the catalyst there in Haber's process?
Ma'am, finely divided ion.
Yeah. And which one is act as a promoter in this Haber's process, Diya?
Molybdenum.
Yeah, molybdenum. Then what about the catalyst in Oswald's process, Naurin?
Platinized asbestos.
Yeah, platinized asbestos. Then what about the catalyst in this contact process? Vidur? Contact process.
Platinum asbestos
Or?
and vanadium.
Vanadium pentoxide. Okay, there are two options, either platinized asbestos or vanadium pentoxide, V2O5. Okay, then today we are going to learn the another section of this chapter, that is colloids. Okay, colloids. Are you familiar with this term? Colloids. You have learned it in 9th standard. Do you remember? We have learned about different types of mixtures, that is homogeneous mixtures and heterogeneous mixtures. Okay, there are two types of mixtures there. Homogeneous mixtures, their composition is uniform throughout that medium. Okay, their composition is uniform throughout that medium. And in the case of heterogeneous mixtures, this composition is not uniform throughout. Non-uniform composition is there. And the examples for this homogeneous mixture, that is solutions, different solutions. Salt solution, then sugar solution, then solid solutions, gaseous solutions also examples for this homogeneous mixture. Okay, alloy is an example for such a solid solution, then air is an example for gaseous solution. So these all belongs to homogeneous mixtures. Then the next section is heterogeneous mixture, and in the case of this heterogeneous mixture there are two categories. First one is suspension and second one is colloids. Okay, all these portions you have learned it in 9th itself. So now we are going to discuss about the second category, that is colloids. Okay, second category, that is known as colloids. Anyone please tell me one example for this colloid? Colloid. Yeah. Gauri? Very good. Milk. Milk is an example for a colloid. Then any other examples? There are different types of colloids that you have already learned. Ink, then different foams, shaving cream, these all are examples of colloids. Okay, so we are going to learn about this colloids now. So I told you it's a heterogeneous system. Just 1 minute children. Yeah, it is a heterogeneous system. That means non-uniform composition throughout. Okay, non-uniform composition. So it's a heterogeneous system in which one substance is dispersed as very fine particles in another substance. It is called dispersion medium. So there are two components for this colloid. First one is dispersed phase and the second one is dispersion medium. Okay. There are two components for this colloids. First one is dispersed phase and the second one is known as dispersion medium. So it's an example for a heterogeneous system in which one substance is not dissolved. Here it is dispersed as very fine particles. Here the particle size is too small. We cannot see it with our naked eyes, but it is big enough to scatter the beam of light. Okay, that means the particle size is in between solution and suspension. solution, then suspension. Here the particle size is in between these two. Okay. In solutions, you know that the particles are dissolved completely in that liquid, right? So particle size is too small. It cannot able to even scatter the beam of light. But in the case of colloid, these particles also we cannot see it with our naked eyes, but it is big enough to scatter beam of light. That's about colloids. And in the case of suspensions, we can able to see the particles. Example, muddy water, then sand and water. These are examples for suspensions. So this colloids has the properties in between solution and suspension. So in the case of this colloid, one substance is dispersed as very fine particles in another substance. Okay, and that is called dispersion medium. And the dispersed substance, it is known as dispersed phase. Okay, so there are two components, dispersed phase and dispersion medium. Then this dispersed phase may consist of particles of a single macromolecule or an aggregate of many atoms, ions or molecules. It can exist in two forms. It can exist even in a single macromolecule or an aggregate of, that means a group of many atoms, ions or molecules. Clear? This dispersed phase may consist of particles. They are in two forms, either in a single macromolecule or aggregate of, that means a group of many atoms, ions or molecules. And here the colloidal particle diameters range from 1 to 1000 nm. What is this nm? Vidur, what is this nm? Which unit is this? Nm?
Nanometer.
Very good. It's nanometer. So here the colloidal particle has a diameter range from 1 to 1000 nanometer. That means too small. Okay. This 1 meter, that is equal to 10 raised to 9 nanometer. Okay. So the particle size is too small here. So I am repeating the points once again. Colloid is a heterogeneous system in which one substance is dispersed as very fine particles in another substance, and that dispersion, that medium is known as dispersion medium, and that fine particles are in dispersed phase. Okay, and these particles of colloids, they can exist in two forms, either as a big macromolecule or aggregate form of atoms, ions or molecules. And their colloidal particle diameter range from 1 to 1000 nanometer. This is clear? Yes, right, children?
Yes, ma'am.
Yes. So can you tell me which are the two forms of mixtures? Adul, which are the two types of mixtures?
Heterogeneous and homogeneous.
Very good. Homogeneous mixtures and heterogeneous mixtures. So Ania, can you give one example for heterogeneous mixture? Not audible. No, dear. Anna, Evelyn, Naureen, Aryan, Michael, please switch on your videos. Nandana, can you tell me one example for this heterogeneous mixture?
Colloids.
Yeah, colloids. Then what about the example for homogeneous mixture, Michael? Homogeneous mixture. That means uniform composition. So you can tell me any example. Yeah, not audible.
Can you say them again?
Yeah, one example for homogeneous mixture. Homogeneous mixture means it has uniform composition throughout.
Lemon.
Yeah,
Lemon.
lime juice. Yes, lime juice is an example for such homogeneous mixture because it belongs to solutions. Okay. Then what about this colloids? Steffi, what is this colloids?
It is a heterogeneous system in which one substance is dispersed as very fine particles in another substance, called dispersion medium.
Yes, okay. Which are the two components of this colloids, Emmanuel? Two components of this colloids.
Dispersion medium and dispersion phase.
dispersing medium and dispersed phase. These are the two components. Okay. Then we are moving to different types of classifications in this colloids. Okay, different types of classifications. Yeah.
Left slide, right, not finish.
Yeah, okay. You can complete it. So you have to remember here the particle size of colloid, it is in between solution and suspension. Okay, we cannot able to see in the particles through our naked eyes, but it is big enough to scatter the beam of light. That you will learn in this chapter itself about the Tyndall effect. Yes, finish, right? Then the first type of classification. The classification based on physical state of dispersed phase and dispersion medium. We have learned that there are two components for this colloids, dispersed phase and dispersion medium. So depending upon their physical states of both dispersed phase and dispersion medium, we can able to differentiate or classify this colloids into different types. Which are the different physical states of matter? Mehak, which are the different physical states of matter? Yeah, solids, liquids and gases, right? So based on the difference in their physical state, we are going to classify these colloids into different types. Okay, the first one. If the dispersed phase is solid and the dispersion medium also solid, it is known as solid sol. Okay, it is known as solid sol. If the dispersed phase and dispersion medium, it is solid, the type of colloid it is known as solid sol. And the colored glasses, gems, etc. are the examples of gemstones. Okay, these are examples of such solid sols. That's the first type. And the second one, if the dispersed phase is solid and the dispersion medium is liquid. Okay, if the dispersed phase is solid and the dispersion medium is liquid, the type of colloid is known as sol. Sol. And the examples are paints, then cell fluids, etc. Which are the cell fluids in the human body? Fluids. Can you tell me which one is the fluid? Gauri, can you tell me which one is the fluid in our body?
Blood.
Yeah, blood. It is considered as a colloid. Okay. It is not completely dissolved, it is dispersed. Then the third one is when the dispersed phase is solid and dispersion medium is gas. Okay, dispersed phase is solid and dispersion medium is gas, it is known as aerosol. Aerosol. So the examples here, smoke, dust, etc. Okay, smoke, dust, etc. So when the dispersed phase is solid and dispersion medium is solid, liquid and gas, different types of colloids obtained, solid sol, then sol, aerosol. Then the next category, when the dispersed phase is liquid and the dispersion medium varies, solid, liquid and gas. So if the dispersed phase is liquid and the dispersion medium is solid, it is known as gel. Okay, it is known as gel. Cheese, butter, jellies, these all are examples of this gel, gel type. Okay. Then the fifth one is dispersed phase is liquid and the dispersion medium also liquid, it is known as emulsion. It's very important. Okay, emulsion. This sol, gel and emulsion, these three are very important. And in this chapter, we will discuss more details about sol and emulsion. Okay, sol and emulsion. So example for this emulsion, that is milk. Okay, milk belongs to this category, emulsion. We learned this milk as an example for colloid in the beginning, right? So milk belongs to the category of emulsion depending upon their physical state of dispersed phase and dispersion medium. Milk, then hair cream also example for this emulsion. Okay. So can you tell me which are the different substances present in this milk? Achyut, any idea? Which are the different substances present?
Fats,
Fats, then
proteins,
proteins, water, etc. Right? That's why it belongs to a mixture. Okay. When you simply looking at this milk, we will consider it as a pure substance. But it consists of different types of particles. That's why it belongs to the category of mixtures. And here it is an example for a colloid. Okay. Here the particles are not completely dissolved. It is dispersed. Okay. Then the sixth one, the dispersed phase is liquid and the dispersion medium is gas. Again it is known as aerosol. Okay. If the dispersed phase is liquid and dispersion medium is gas, it is known as aerosol. And examples here, fog, mist, cloud, etc. Fog, mist, cloud, etc. Then the seventh one, if the dispersed phase is gas and the dispersion medium is solid, again it is solid sol. So here the repetition of solid sol and aerosol. Okay, solid sol and aerosol. And the examples are pumice-stone, foam, rubber, etc. What is this pumice-stone? Pumice-stone, children?
from lava,
Yeah, that means what's the purpose of this pumice-stone?
is used on skin.
Yeah, to remove the dead cells from the skin, we are using this pumice-stone. So it's a type of solid sol. Okay. Then the eighth one, if the dispersed phase is gas and the dispersion medium is liquid, it is known as foam. Okay, it is known as foam. So the whipped cream, soap, lather, etc. are examples of such colloids. Okay, and this category, that means gas in gas, that is not considered as a colloid. Okay, gas in gas, it is not considered as a colloidal system. Gas in gas is not a colloid. So there are 8 types of colloids based on their physical state of dispersed phase and dispersion medium. Clear, children? There are 8 different types of colloids based on their physical state of dispersed phase and dispersion medium. Aditya, can you please read the types of colloids? Yes.
Solid, solid,
Yeah.
solid, solid. Example, colored glasses, gems,
Yeah.
etc.
Mm.
Then solid liquid
Yeah.
is salt, paint, cell fluids.
Examples. Okay. Then
Examples, solid gas is aerosol. Example, smoke, dust.
yes.
In liquid solid is gel. Example, cheese, butter, jellies. Then liquid is emulsion. Example, milk, hair cream, etc. Then liquid gas is again aerosol. Is fog, mist, cloud. Then gas solid is solid sol. Example, pumice-stone, foam, rubber, etc. Then gas liquid is foam. Example, whipped cream, soap, lather, etc.
Okay.
Gas and gas is not a colloid.
Not considered as a colloid. Okay. And among this, gel, then emulsion and salt. These 3 are important ones. And in this chapter itself, we will discuss about sol and emulsion. Okay. Sol and emulsion. Okay, Rijas, can you please repeat these points in the table?
Solid and solid, salt. Example, color glass, gems.
Okay.
Solid and liquid, salt. Example, paints, cell fluids. And solid and gas, aerosol. Example, smoke, dust.
Okay.
Liquid and solid, jelly. Example, cheese, butter, jellies.
Okay.
Liquid and liquid, emulsion. Example, milk, hair cream.
Yeah.
Liquid and gas, aerosol. Example, fog, mist, cloud.
Yes.
Gas in solid, mixed form rubber.
Yeah.
Gas in liquid form, example, whipped cream, soap, leather.
Yeah, whipped
Gas
cream,
in gas
soap.
is not a colloid.
Not a colloid. Okay. So these are the different types of colloids depending upon their physical state of dispersed phase and dispersion medium. This is the first type of classification. Have you completed this slide, children? All of you? Any doubt here? Please switch on your videos. Malavika, Alvin, Muhammad Adi, Meenakshi, Gayatri, Srihari, Donna, all of you. Then we are moving to another type of classification in the case of this colloids. Okay, the second type of classification. Classification on nature of interaction between the dispersed phase and dispersion medium. The nature of interaction between this dispersed phase and dispersion medium. First one, it is depending upon their physical states. Okay, physical state of dispersed phase and dispersion medium. And the second classification, it is based on the nature of interaction between dispersed phase and dispersion medium. Okay, so based on this nature of interaction, we can able to classify this colloids into two types. First one is lyophilic colloids. Lyophilic colloids. And the second one is lyophobic colloids. Lyophobic colloids. What do you mean by philic? Philic. Lyophilic. Yes, Steffi? Anything to share?
Attracting or
yes,
toward.
very good. Yes, attracting or loving. Okay, philic means attracting or loving. Then what about phobic? Phobia. What's the meaning of phobia, Anna? Fear or hating, right? So here there are two types of colloids based on their nature of interaction between the dispersed phase and dispersion medium. First one is lyophilic, that means liquid loving or liquid attracting. Okay, liquid loving or liquid attracting. And the second one is lyophobic, that is liquid hating or they are away from liquid, that's it. So these are the two types of colloids based on the nature of interaction between dispersed phase and dispersion medium. Okay. So lyophilic means liquid loving. Okay, lyophilic means liquid loving. That's the first point. Lyophilic means liquid loving. And the lyophobic means liquid hating. Lyophobic means liquid hating. So in the case of this lyophilic colloids, they always attracted towards this liquid. Okay, they have strong force of attraction between liquids. In the case of lyophobic colloids, they always hate liquids. That means weak force of attraction between liquids. That's it. Okay, then we are moving to the properties of this colloids, lyophilic and lyophobic colloids. These lyophilic colloids, they are formed by mixing substances like gum, gelatin, starch, etc. with a suitable liquid. Okay, these are just formed by mixing substances like gum, gelatin, starch, etc. with a suitable liquid. Because they are attractive towards this liquid, we can able to form this type of lyophilic colloids by simply mixing the substances like gum, gelatin, starch, etc. with a suitable liquid. Okay, that is known as lyophilic colloids. That's the method of preparation of this lyophilic colloids. And in the case of lyophobic colloids, these are formed by using specific methods, not simple mixing of this substance into liquid. It is not possible here in the case of lyophobic colloids. Here we have to use certain specific methods. And in this chapter itself, we will learn different types of preparation of this lyophobic colloids. Okay, there are specific methods for that. These are formed by using specific methods, not when metals are simply mixed with dispersion medium. It's not possible by simply mixing the substance with the dispersion medium. So that's the main difference between lyophilic colloids and lyophobic colloids. The method of preparation, it is entirely different. In the case of lyophilic colloids, it is simply mixing that substance in the liquid medium, suitable solvent. Okay, but here it is not formed by mixing the substance with the dispersion medium. Here the specific methods are used for the preparation of lyophobic colloids. Okay, then we are moving to the third point. If dispersion medium is separated from the dispersed phase. If the dispersed medium, it is separated from the dispersed phase. If it is in the liquid form, we just remove that liquid from that colloid. What happens here? Salt can be re-achieved by remixing with dispersion medium. If liquid is considered as the dispersion medium here, and we just remove that liquid from the substance and we again add this liquid into that substance, it will be again back to its colloidal form. That means they are reversible salts. Okay, they are reversible salts. I will repeat this point once again. If dispersion medium is separated from dispersed phase, if the dispersed medium, it is separated from dispersed phase, the salt can be re-achieved. That means the colloidal form is re-achieved by simply adding that dispersion medium. That means it is reversible in nature. Okay, if you remove water from that colloid and we again add water to that colloid, it can able to regain its colloidal property. That's it. That's why it is considered as a reversible salt. Reversible salt. And in the case of this lyophobic colloids, if dispersion medium is separated from dispersed phase, salt cannot be re-achieved by remixing with dispersion medium. Here we cannot able to regain this colloidal property by simply adding the dispersion medium, because here this lyophobic colloids are prepared by specific methods, right? Not by simply mixing. So when you remove this dispersion medium from that colloid and again adding this dispersion medium, it is not possible to maintain its colloidal state here. That means it is considered as an irreversible salt. Irreversible salt. That means reverse reaction not possible here. Reverse reaction not possible here. Then in the case of lyophilic colloids, they are very stable. They are very stable. And lyophobic colloids, they are very unstable. And in order to maintain this lyophobic colloids as stable, we need to add stabilizing agents. Okay, there are certain agents that increases their stability. They are known as stabilizing agents. It is used for their preservation. To maintain this lyophobic colloids for a long time, we need to add stabilizing agents because it's in an unstable state. So these are two different types of colloids depending upon their nature of interaction between the dispersed phase and dispersion medium. Lyophilic colloids and lyophobic colloids. Okay, lyophilic colloids and lyophobic colloids. This is clear, children?
Yes.
Yes. Shivani, can you tell me which are the two types of colloids depending upon the nature of interaction between dispersed phase and dispersion medium? Not audible. Yes. Yes, Shivani? Which are the two types of colloids depending upon the nature of interaction between dispersed phase and dispersion medium? Yeah, lyophilic colloid and lyophobic colloid. Have you completed the slide, children?
No, ma'am.
Okay, then you can complete.
One more line.
Okay, fine. Have you completed?
Yes, ma'am.
All of you?
No, ma'am. 1 minute.
Okay, okay.
Finished, ma'am.
Finished, right? Okay. Then, Punya, what's your doubt here? Punya? Yeah.
In the textbook, butter is in liquid.
Ah, okay, okay, emulsion, right? Okay. I will check this and inform you, okay? Yes. Butter is in liquid. That means butter belongs to gel or emulsion. Okay. I will check and inform you in the next class, okay? So these are two different types of colloids based on the nature of interaction between dispersed phase and dispersion medium. So can you tell me any one property of this dispersed, that means lyophilic colloids and lyophobic colloids? Meenakshi, can you tell me any one point?
Lyophilic colloids are very stable, and
Yeah.
lyophobic colloids are not stable.
Not stable. Okay, Punya, can you tell me another point?
Lyophilic are liquid loving. Lyophobic are liquid hating.
Okay. Then Gayatri, can you tell me another one?
Lyophilic colloids have reversible salts and lyophobic has irreversible salts.
Yes. Then Anna, can you tell me one point?
Lyophilic is formed by mixing certain substances.
Yes.
Whereas lyophobic is by special methods are used.
Yeah, specific methods are used. So this is the second type of classification based on the nature of interaction between the dispersed phase and dispersion medium. Then we are moving to the third type of classification. Okay, third type of classification. Classification based on type of particles of dispersed phase. Okay, classification based on the type of particles of dispersed phase. In the beginning itself I told you sometimes the particles are in exist as single macromolecules, or otherwise it is just the aggregate or the groups of atoms, ions or molecules, right? So here based on the type of particles of dispersed phase we can able to classify these colloids into different types. And the first one is multimolecular colloids. Okay, multimolecular colloids. Multimolecular colloids. On dissolution, many atoms or smaller molecules of a substance aggregate together to form species having size in the colloidal range. That is called multimolecular colloids. You have to not write this part. Okay. It's in the colloidal range, that's it. On dissolution, many atoms or smaller molecules of a substance aggregate together, that means joins together to form species having the size in the colloidal range. Okay, they have the size in colloidal range. Such types of colloids are known as multimolecular colloids. Multimolecular colloids. For example, a gold salt, which may contain particles of various sizes having many atoms. So in the salt, it is in the form of a colloid. That means their particle sizes aggregate together in the size of a colloid. Okay, so gold salt is considered as an example for this multimolecular colloids. Then the another one, sulfur salt. Sulfur salt. So here many atoms or smaller molecules of substance, they aggregate together to form the species having size in the colloidal range. Colloidal range, that is 1 to 1000 nanometer. Okay, 1 to 1000 nanometer. That's the colloidal range. Example is gold sol, sulfur sol, etc. Multimolecular colloids. Anthony, can you hear me? Anthony? Yes, can you please read the slide?
Classification based on type of particles of dispersed phase. Multimolecular colloids on dissolution, many atoms or smaller molecules of a substance aggregate together to form species having size in colloidal range called multimolecular colloids.
Yes.
For example, a gold salt may contain particles of various sizes having many atoms.
Then sulfur sol is another example for this multimolecular colloids. Okay, we completed. So this is the first type. Depending upon the type of particles of dispersed phase, it is known as multimolecular colloids. Okay, multimolecular colloids. And the second one is this macromolecular colloids. Macromolecular colloids.
Now sulfur sol example.
Yeah, sulfur sol is another example. Okay. Second one is macromolecular colloids. Macromolecular colloids. So macromolecules, that means the molecules that are bigger in size, right? Macro. That's the difference between micro and macro, isn't it? Micro, that is too small. Macromolecules, that is big in size. So macromolecules in suitable solvents form solutions in which the size of the macromolecules may be in the colloidal range. Such systems are called macromolecular colloids. So here this macromolecules, they are dissolved or they are dispersed in suitable solvents and form solutions, and these solutions are in the range of colloid. It belongs to the category of macromolecular colloids. Okay, macromolecular colloids. Certain macromolecules, they are dispersed in suitable solvents to form solutions, and these solutions have the range, that means size range, that in between colloids. That means similar to that of colloids. Such systems are called macromolecular colloids. And the examples are certain naturally occurring macromolecules. They are starch, cellulose, proteins and enzymes. And those of man-made macromolecules, polythene, nylon, polystyrene, synthetic rubber, etc. That means different polymers. So these are certain macromolecules. When they are dispersed in suitable solvents, if they are in the size, their size in the range of colloids, they belongs to the category of macromolecular colloids. And there are naturally occurring macromolecules and man-made macromolecules. In the case of naturally occurring one, starch, cellulose, proteins, enzymes, etc. And in the case of man-made macromolecules, polythene, nylon, polystyrene, synthetic rubber, etc. Okay. Krishna? Krishna, can you hear me? Can you please read the slide? Krishna.
Macromolecular colloids. Macromolecules in suitable solvent form solutions in which the size of the macromolecules may be in colloidal range. Such systems are called macromolecular colloids.
Yeah.
Examples of naturally occurring macromolecules are starch, cellulose, proteins, and enzymes. And those of man-made macromolecules are polythene, nylon, polystyrene, and synthetic rubber, etc.
Polystyrene, synthetic rubber, etc. And this type of colloids, they are stable in nature. Okay, and they resembles that of true solutions. These colloids are stable and they resembles true solutions. And there is one more category in this one, associated colloids, that we can discuss in the next class. Okay. So depending upon the type of particles of dispersed phase, there are three types of colloids. First one is multimolecular colloids, second one is macromolecular colloids, and the third one is known as associated colloids. Okay. We can discuss about associated colloids in the next class. Have we completed, children? No.
Yes, ma'am.
Okay. Okay, then we can discuss the remaining topics in the next class. Okay. Now let me take your attendance. Just wait. Thank you all. See you in the next class. Bye. Thank you.
Thank you, ma'am.
Thank you.